Okay, so now we're going to start Unit 2. So on page 9, I'm going to write Unit 2, and this unit is on justification and similarity. And this is page 9. So, Unit 2, Justification Similarity on page 9. The first thing that we are going to be taking notes on page 10, is triangle congruence. So, triangle congruence. Now, this will be a review from Integrated 1. We did talk about this in Integrated 1. But there are some theorems that go along with it. But the definition of congruent is polygons are congruent when all corresponding parts are congruent. And that may seem pretty obvious, but the word corresponding is very important. If the side length of one triangle and the side length of another triangle are congruent, that doesn't necessarily mean the triangles are. They have to be in the same place in the triangle, which means corresponding. So there are some shortcuts. So I'm going to write triangle congruence shortcuts. And these are all the theorems that make triangles congruent. The first one is SSS, which stands for side, side, side. That means that all sides in the triangles are, the corresponding sides in all the triangles are congruent. So over here, I'm going to draw a little example of what it would look like. We could have that triangle and this triangle. And then I'm going to make some markings on the sides. This side is congruent to this side, let's say, this side, that side, and then those sides. And you can see which sides are congruent to each other. This one has 1 dash, that one has 1 dash, 2 dashes, and 3 dashes. That's how to determine what are corresponding parts. So then we have SAS. Which stands for side, angle, side. That means we have two sides congruent and the angle between them. So it could look like this. We have triangles. We have side, the angle between them, and then the side. Side, angle, side. It must be in that order in order for it to be side, angle, side. It must be the side, and then the angle between them, and then the other side length. ASA is the next one, which is angle, side, angle. And I'm going to draw different looking triangles this time. So angle, side, angle. We have an angle, the side between them, and another angle. angle, side, angle. You'll notice these have double arches. That means those are the corresponding angles. But we have an angle, the side, and then the angle in that order is important. Angle, side, angle. The next one is angle, angle, side. Or you can also say this as side, angle, angle. They're the same thing. This is just you have two angles and then a side congruent. So we have an angle, another angle, and then the side that's not in between them. Angle, angle, side. Like I said, it could also be called side, angle, angle. Angle, angle, side, side, angle, angle. And then the last one that we have is HL. And that stands for hypotenuse leg. And hypotenuse leg is a different one because the only time you can use hypotenuse leg is when you have a right triangle. So hypotenuse leg is only for right triangles. And that's really, really important to remember. You can't use hypotenuse leg unless you have unless you have two right triangles. And what that would look like is if we had this right triangle, and we know it's a right triangle because of that. And we have this right triangle. We have the hypotenuse is congruent, so those are the hypotenuses. And then we have a leg congruent. Hypotenuse, leg. This is the hypotenuse on a right triangle. These are the legs. You must have a hypotenuse and the leg congruent. So those are the triangle congruence shortcuts. There's also a couple of properties that I do want to have on this page too. So I'm going to go ahead and move this down. And they go along with this, but they're not exactly the same. So I'm going to draw a line here. And there's going to be three things that I want to talk about with this. The first thing I'm going to talk about is vertical angles. Now, we've talked about vertical angles before, but this is going to be in terms of triangle congruence. So vertical angles. And we can see vertical angles a lot when we're trying to prove congruence. So let's say we have triangles that look like that. Okay, those are two triangles. We have this first triangle, and then we have this second triangle. Now what you will need to know is that this angle and this angle are congruent. These are congruent because they are vertical angles, okay? So we have to note that those are congruent because they're vertical angles. The second thing that you need to note is reflexive property. And we will use this a lot when we're trying to prove congruence. So reflexive property is when you have something that looks like this. Here, again, we have two triangles. We have this first triangle, and then we have this second triangle. Okay? We use reflexive property to prove that this side is congruent to itself. That's what reflexive property says. We have to know that to say that that is congruent to itself. So let's say that we had this triangle, and let's say it was A, B, C, D. You could say that BC is congruent to BC. BC is congruent to BC because it's a reflexive property. So you would say by the reflexive property. Okay? That's what reflexive property allows you to do. And then the very last thing we're going to talk about is Pythagorean theorem, which should be a review. But Pythagorean theorem helps you find side lengths of a right triangle. It must be a right triangle, so I'm going to draw a little right triangle right here. Okay, and we have side lengths A, B, and C. So the important things to note on Pythagorean theorem is must be a right triangle, and C is always across from that right angle. The A and the B don't matter, but C must be across from the right angle. And this is A squared plus B squared equals C squared. And that's Pythagorean theorem.